In this video, we'll be looking at Chapter 15, Section G on vector equations. Now, solving vector equations is essentially the same thing as solving algebraic equations, with one exception, and that is we cannot divide by a scalar on both sides of an equation. For example, if I have the vector equation 3 times vector x equals vector A, and I want to solve for vector x, then vector x is equal to 1/3 vector A, not vector A divided by 3. So instead of dividing by a scalar, we multiply by its reciprocal. And that's because we don't really know how to divide a vector by a scalar. We've been dealing with scalar multiplication, so we want to stay in those terms. We want to multiply a vector by a scalar and not divide by a scalar. But otherwise, solving a vector equation is very, very similar. And to just reiterate this one more time and to put it into general terms, if I have a scalar k and I multiply by vector x to get vector A, then we have vector x is equal to 1 over the scalar k times vector A. And so let's take a look at an example problem. Okay, in this example problem, we want to make vector x the subject of this vector equation. And making x the subject of is really another way of saying solving for vector x. So normal algebraic rules apply. I want to get vector x alone, so I'm going to move vector r over to the right-hand side by adding vector r on both sides of the equation. And that gets me 2 times vector x equals vector p plus vector r. And to get vector x by itself, remember we need to multiply by the scalar, or the reciprocal of this scalar. I can't divide by 2. So instead, I'm going to multiply the entire right-hand side, or actually both sides of this equation, by 1/2 to get 1/2 times vector p plus vector r. So this is the solution, the correct solution for this vector equation. Let's quickly take a look at one more example. Again, we want to solve or make vector x, the subject of this equation. So I want to get vector x by itself. In this case, we want to subtract vector n from both sides of the equation. And that will leave us with -3 times vector x equals vector m minus vector n. And again, to move that -3 over, I'm going to multiply both sides of the equation by its reciprocal, which is 1 over -3. And therefore, vector x is equal to -1/3 vector m minus vector n. And to make this a positive scalar, I can distribute that -1, and this is how your book does it, so that we have a positive scalar here. And that's going to get me minus vector m plus vector n, which we can rewrite as vector n minus vector m. And this is the form that your book puts the solution into. So let's go ahead and follow that example. But again, you can see that we're really just using normal algebraic expressions or operations with the exception of multiplying by the reciprocal instead of dividing.